What up, my people? After watching this video, you will be able to write an equation that models exponential growth or decay. Let's get it.
Yeah.
Let's begin with some vocabulary. So in this situation, when we're dealing with exponential growth or decay, we're going to be using this formula. We have A is equal to P 1 plus or minus R to the T power. The A is going to be the amount after time T. The P is going to be the present value or the initial amount. That could also be called the principal. The R will be the rate, and we may have to convert that to decimal depending on if it's expressed as a percentage. And the T is going to be the time. And the function will be 1 plus R if we're dealing with a growth. The function will be 1 minus R if we're dealing with a decay. For example number 1, to begin a study, a petri dish had 1900 bacteria cells. Each hour since, the number of cells has increased by 17%. Let T be the number of hours since the start of the study. Let Y be the number of bacteria. Write the function showing the relationship between Y and T. So in this case, we're going to be dealing with, this is basically a word problem, and we're going to just see what values line up with our formula that we used from before. We have 1900 bacteria cells, and that's to begin a study. So this is going to be our initial amount, which will be our P. And for each hour since, the number of cells has increased by 17%. So 17%, that's going to be our rate. And T is going to be the number of hours since the start of the study. So the T is the hours since the start of the study. So all we're going to do is just plug that in to find the relationship between the Y and the T. So our Y again is going to be the value after time T. Our initial amount is going to be the P, which we have as 1900. It says it increased. So because it increased, it's going to be 1 plus 17%. And 17% is a decimal. Is going to be, we take our dot from here, or our decimal point from here, we move it 2 spots, and put it here. So that means it's going to be equal to 0.17. So 0.17, and then time T is going to be T. And that's it. That's how we express our relationship. All right, for example number 2, a car was purchased for $18,500. After each year since, the resale value has decreased by 29%. Let the T be the number of years since the purchase. Let Y be the resale value of the car in dollars. Write an exponential function showing the relationship between Y and T. So again, we're going to read through this and we're going to just mark what is what. So at the beginning, we have the car was purchased for $1850. That's going to be the initial amount. That's going to be our P. Each year since, the resale value has decreased by 29%. We have a decrease, so we're dealing with 1 minus R. And then 29% is going to be the R. And T is going to be the number of years since the purchase. So let's write that right there like that. So now we just need to use our formula that we had from before. We have our Y is equal to the initial amount. So we have $18,500. We're going to be decreasing, so it's going to be 1 minus. Our rate is going to be 29%. So to convert that again, we have 29% is equal to, let's make that percent better. We move our decimal place 2 places, 1, 2. So it's going to be 0.29. So we're going to put 0.29 over here. And then our relationship is going to be with T. And that's going to be for time T for the number of years. We could also subtract. And we could also rewrite that as Y is equal to 18,500. 1 minus 0.29 is going to be 0.71 raised to the T power. And that's it. All right, we're at that point. Here's a problem for you to try. There will be a link to the solution in the description. Please like, share, and subscribe for more tutorials. And please ring the bell to make sure that you're updated with all of our new content. Thank you for taking the time to invest in yourself and making a weakness a strength. Ashe.